First of all, thank you all for joining this session. So for today's presentation, I'll be talking about my research paper entitled Investigating Problem-Solving Approaches of Students in MOOCs Using Natural Language Processing. So I'll first talk about background and then the research framework and methods I use in my research. And then I'll share some of my experimental research. And lastly, I will discuss some of the opportunities and challenges. Okay, so as you all know, like MOOCs, massive open online courses, is a very popular and prevalent mode of educational delivery these days. And particularly with the outbreak of COVID-19 in only 2020, many universities and students around the world are now conducting their educational activities on online platforms like MOOCs. So in 2021, like around 19,000 MOOCs were announced or launched by around 950 universities worldwide. And in 2021 alone, around 3,000 courses were added. So, as you can see on the graph, there has been an exponential growth of MOOCs in recent years. But there are some like inherent challenges of MOOCs. One of it is online learning requires different learning engagement and behaviors of students compared to traditional classroom learning. Classroom learning is usually teacher-centered or passive learning, where the instructor controls the classroom dynamics. Whereas in online learning, students independently analyze the information and adopt a diverse set of skills and self-directed learning strategies to successfully digest the knowledge. So there's a strong need in identifying and understanding how students are behaving differently compared to the in-person learning in order to apply appropriate teaching methods and strategies for the online learners. But however, this is very challenging because the limited interaction between students and instructors and also the large size of class that MOOCs usually have make it really hard to monitor and understand the learning behaviors of students. So we try to first look into what kinds of efforts were there to address these challenges. So we did an extensive literature review. You can see in my research paper some of the key examples of research papers that we investigated, as you can see on the right side. And after reviewing these papers, there were some potential research gaps we identified. First is many of the previous research focused on the use of event log or quick stream data that are recorded by the online learning platforms like MOOCs. And many of these data were used to analyze the learners' behaviors or predict their academic performances. But only a few research on the students' problem-solving approaches, which carries a very insightful information about how students behave and how they learn knowledge. And also on the technical part, topic modeling, which is used to detect topics, is one of the very popular NLP, natural language processing techniques used to analyze the students' reviews of posts. And many of the papers that we reviewed were mainly using statistical models such as LDA or LDA modified models, which I will describe more in the later slides. Okay, so our research paper seeks to shed a new light on the less explored part of online learning activities by proposing a framework that captures the holistic spectrum of students' learning activities that are carried out not only inside the MOOC platform, but inside and outside the MOOC platform. And for that, we wanted to suggest a research method that can analyze the MOOC users' problem-solving approaches at scale. And also, we propose an NLP pipeline that applies advanced preprocessing methods and also uses a contextual language model and also a text summarization model to enhance the accuracy and also readability of topic modeling research, which usually has a very very poor readability for the end users to understand. So I will talk about our research framework. So For our research, we used user-generated text data. We collected from 5,421 students. We collect this through the online survey to analyze their problem-solving methods. So as you can see in this diagram, first, after the data collection, we go through this pre-processing stage, which scans and clean data, and also extract key information from the unstructured text data to reduce the noise. And also, after that process, then we go through a topic modeling stage where we detect topics. And then with that topics, we use the text summarization model in order to generate the narrative summaries. So in general, topic modeling outputs the keyword-based results. So most of the time, the researchers or users have to make predictions, make inferences based on that keywords, what it is talking about. But we use this text summarization to convert that into a narrative form in order to improve the readability. So in the end, we also wanted to see this output in the lens of education. So we use a couple of existing education framework to try to interpret our results into educational implications. So I will go details for each stage. So for the data collection stage, the data was collected from the MIT Computer Science course. It is a MOOC hosted by edX. It is taught over 9 weeks in spring 2021. So after an exercise, students were randomly selected using the built-in A/B testing feature. And the survey asked the students to describe their problem-solving approaches. So in total, we collected over 44,000 responses from over 5,000 students. But there were also like unanswered responses. And so we did a initial filtering and to select about 7,400 responses to conduct our research. So once the data was collected, we had to go through text preprocessing stage because generally user-generated text data are very noisy, has a lot of noise. So we employed a chain of 8 preprocessing steps, as you can see on the right side. So we use the initially filtered responses to feed into the preprocessing pipeline. And as a result, we only had 1,644 responses that survived through this process. It was about 78% of the total responses were discarded. But although we had a very high loss of data, because of this preprocessing stage, the performance of topic modeling improved significantly, and we observed about 18% improvement. So in the next stage is topic modeling, where we detect the topics. So we experimented 2 different methods. First is statistical-based models, which is also called bag of words models. For this, we use LDA and GSD-MM. They are both popularly used to discover hidden topics from text corpus. And GSD-MM is a modified LDA and also well known for its outstanding performance on short text. And our text data entries, about 64% were less than 10 words. So we decided to include GSD-MM to compare the performance with LDA. But the limitation of these statistical models is that it is incapable of capturing contextual information, which can be very detrimental to the overall performance. So we also implemented a transformer-based topic modeling using BERT, which is also very popular contextual language model, and it is capable of capturing the contextual information of sentences. So first we use BERT to convert the text data into the sentence embedding. And then with that converted embedding, we use a clustering algorithm to cluster the data based on their semantic similarity. So we use a B-cube evaluation matrix to measure the performance. So here, the performance of topic modeling is measured by the accuracy of the text clustering. So how well the model groups the text inputs into a correct set of topics. And after this experiment, we found out that BERT combined with DB-scan clustering algorithm had the best performance. So we used that set of combination to conduct our research. So once the texts are grouped into the same topics, we use text clustering, text summarization, sorry, to create this, generate this summaries of topics. We use Pegasus, which is a pre-trained text summarization model to perform the text summarization. And then ROG metrics is generally used evaluation metrics to measure the performance of text summarization. So we use that. And we also included one more evaluation method, which is length of generated summaries, because the ROG metrics tends to give a better score to the lengthy sentences sometimes. So we wanted to address that limitation by setting a right length of generated summaries. And if the summary goes too much above that length, we kind of penalized it. So after this experiment, we identified that Pegasus paraphrase, that's a pre-trained model from Hugging Face to select that had the best performance. So we selected that model. And we also went through a little bit of fine-tuning process to improve the performance, optimizing the model using our own training data. So in the last days, once we got all the results, we tried to use these two existing educational frameworks to interpret that into the lens of education. So first, a test structure framework. It's a pretty simple. Basically, what we do is we first identify the problem-solving methods, and then we try to formulate that into a subtask here. So we kind of group the methods that are aiming to do the similar task. For example, for peer learning, there were the methods could be like ask on the discussion forum or ask friends and things like that. And for coding as well, maybe test on the IDE or also coding using a trial and error methods and things like that. And then secondly, we also look into the active passive learning framework. This framework defines whether students are actively or passively involved in the learning process. So some of the examples of active learning could be like using online discussion forum or doing a group project and things like that. Whereas passive learning, it's mainly just doing a reading or listening to the lecture or watching a video where you just literally just receives the information. Okay, so I will share some of the results. So this is the result of the topic modeling. As I said, it comes out into a keyword format. So based on our 1,644 responses, we identified 18 problem-solving methods. So as indicated here, code, step, try is the most frequently used problem-solving approach by the students, followed by a video loop lecture and also answer check question. But just by looking at this, you can get a sense what it's trying to say, but some of them, sometimes it gets really hard. So that's why we integrated text summarization model into this pipeline. So once the topic is created, we put that topic's data entries that belongs to that topic into this text summarization model. So what we get here is code step try. This is the summary generated by the AI. It says that I try to step through the problem by writing the code on the piece of paper. So, and video loop lecture, use the knowledge from the video to answer the question and things like that. So, so by using text summarization model, we were able to improve the limited readability of the topic modeling outputs. So, so with these outputs, we try to use the education framework to interpret that in the lens of education. So first, we have identified 5 tasks based on the identified problem-solving methods. As you can see here, the knowledge construction, social peer learning, understanding the problem, clarifying code logic, and coding and debugging. So these are the 5 tasks that we group all the problem-solving methods into. So so the methods includes like checking online resources, watch lecture videos, look lecture material, use previous knowledge. And we also try to use the creator metrics to categorize the problem-solving approaches in the 2-dimensional space, like task structure versus active-passive learning. So we place the approaches in the metrics according to their corresponding tasks and activity-ness of learning. So yeah, so here upper table is active learning, whereas the methods that are in the lower part of table is considered passive learning. So so in the interest of time, I'll skip to the discussion. So there were some like things that needs to be considered for opportunities. I think the enhancement through transformer model was very obvious, rather than using statistical model. By using the transformer-based topic modeling model, the performance improved significantly. So, for example, if you use first sentence embedding combined with DB scan clustering algorithm, we achieve around 68% accuracy compared to 60% by LDA and 24% by GSDMM. So the performance is quite different depending on what kind of model you're using. And also by integrating the text summarization model into the topic modeling pipeline, this will provide a solution to improving the limited readability of keyword-based research of topic modeling. There were also some challenges. Preprocessing plays a critical role in improving the quality of topic modeling, but we have to suffer some of a great loss of data. So I think this can play as a constraint for small data with a high level of noise. So you have to balance between the quality and also how much data you have. And capturing the multiple approaches is also an issue, because the shortcoming of this approach is you only can capture one topic per data entry, so per single sentence. So this approach cannot detect how many methods are used by a single student. And lastly, improving the output quality. There are rooms for improving the clustering and summarization quality, because these days we have GPT-4 and ChatGPT that are showing like incredible performance in terms of text summarization and also any like tasks related to natural language processing. So maybe we can integrate that in this research in order to improve the performance, and that's something to be considered. Okay, so thank you, and thank you for listening, and that's all for my presentation.